So what we can do is we can actually calculate the entropy of a reaction from absolute entropies of individual molecules that we're discussing. So this is very similar to how we calculated the enthalpy of a reaction by taking the change in enthalpy of formation, except we don't even have to worry about a change in entropy because we can talk about entropy as an absolute value. There's an absolute zero in terms of entropy where there is no disorder at all. And this is described for any molecule as being its perfect crystal at absolute zero. So this is where we're going to say there's absolute complete order. There's no disorder at all in this system. So what we can take to calculate the entropy in a reaction is just to take the sum of the entropy of all the products and subtract from that the entropy from all of the reactants. So let's try this for the example that you just did on the clicker question and make sure that our calculation matches up with our prediction here. So again, we're just going to take the sum of the entropy of the products minus that of the reactants. So if we talk about this, we're starting with our products. So our first product is water. And what I want to point out is you need to make sure you multiply this by 2 because, in fact, we have 2 moles of water that are formed here. OK, I'm so sorry. Yeah, so yikes. This should be water. You know what? Let's just write this on the board. So we're going to talk about delta S of the reaction. So that's going to be sum of the entropy of the products. So we're going to be talking about 2 times the entropy of water. And we'll add to that our other product, which is molecular oxygen here. And we don't have to put a subscript, or we don't need to put a number out here because it's just 1 mole. So that's of O2. And we'll subtract from that the entropy of hydrogen peroxide here. And do we need to put anything out here for this? 2, yeah, because there's 2 moles there. So water plus oxygen minus hydrogen peroxide. Let's hope I at least got the values right. All right, so this is ignore, please. Yeah, and actually I think this is right. I believe this is the entropy of water. So OK, so the actual numbers are right here for what is written on the board and hopefully in your notes. So what we find out is that the entropy of this reaction here, the change in entropy, the delta S, is 125 joules per K per mole. All right, so we can also, well, first, we already thought about why delta S is positive. Delta S is positive because we're going from a liquid to a liquid and a gas. We're increasing our disorder. So let's think about whether this reaction is spontaneous or not. And to do that, we actually need to go ahead and completely calculate delta G. So to do this, we can take our values here. And delta G is equal to delta H minus T delta S. So if we plug all of this in, we have our delta H is negative 196 kilojoules per mole minus our temperature. And I wanted you to write this in again because I want to make sure you get in the habit of converting our joules to kilojoules. It's 0.125 kilojoules per Kelvin mole. So we end up with a delta G of negative 233 kilojoules per mole. Is that spontaneous or non-spontaneous? Great, so the reaction here is spontaneous.